Hello everyone. I want us to have a quick look at question number 16 on your pre-mock paper. And this is a question about surface areas and volumes of 3D shapes, more specifically a sphere and a cylinder. So let's read the question first. It says the diagram shows a sphere and a solid cylinder. The sphere has a radius of 6, the solid cylinder has a base radius of 3 centimeters and a height of h centimeters. All of this is annotated on your diagram. The surface area of the cylinder is twice the total surface area of the sphere. Work out the ratio of the volume of the sphere to the volume of the cylinder. Give your answer in the simplest form. We must show all our working out. So I've written at the top here, this was originally in a non-calculator paper, so paper 1H for November 2016. Now I think at that point you still would have had your formula page at the front of your paper. That's not the case for you guys anymore, but from what I've seen in your specification, they still do give like these tricky volumes. So for example, in this case, they would have given you probably the volume and the surface area of a sphere. The cylinder is a bit more straightforward and maybe more easier to just think about how you'd get them. So I'm gonna start by identifying what are they asking me. So I need surface area and I also need volume. So I'm going to quickly write my formulas for both these things for both my shapes. So the surface area of a sphere is equal to 4 pi r squared, and the volume of a sphere is equal to 4 over 3 pi r cubed. Now let's have a look at the cylinder. So for my cylinder, it's kind of easier to think about how you get these formulas. So I need to, for surface area, I need to have the area of this curved bit here, which obviously goes all around the shape, and that would be equal to the circumference of your circle multiplied by the vertical height. So the circumference of the circle is 2 pi r multiplied by the height of the cylinder, which is h, and that covers, if you were looking at this and it was a tin of something, it would be the label that goes all around the tin, the area of that label. But we also need to add the areas of the circles at the top and at the bottom of this shape. So I'm going to add 2 lots of the area of a circle, which is pi r squared. So that's the surface area of a cylinder. For the volume of a cylinder, we have to do the area of the cross section, which in this case is a circle, obviously. So we're doing the area of the cross section, which is pi r squared, and we multiply that by the height. So I've got all my formulas, rather, because there's loads of them. There's 4 of them. Now I can start. So the total surface area of the cylinder is twice the total surface area of the sphere. So I'm going to start making some surface area calculations, okay? And I'm going to start with the sphere. The surface area of the sphere, is equal to 4 times pi times the radius squared. So that would be times 6 squared. And I'm going to do the same for the surface area of my cylinder. So for my cylinder, that's going to be a bit more of work. So the surface area of the cylinder is equal to 2 pi times the radius, which is 3, times the height, plus 2 pi times the radius squared, which is 3. So I'm going to try to simplify this as much as humanly possible here. I'm going to go back to, actually, now let's finish the cylinder first. So the surface area of the cylinder. So in this first bit, I can tell that 2 times 3 is 6. So I've got 6 pi. The h can't do anything with it, so I keep it. So 6 pi h from the first bit. And then 2 times 3 squared, that's 2 times 9. So that's plus 18 pi from the second bit. And in this bit, I've got 4 times 6 squared. So 6 squared is 36, and 36 times 4, 6 times 4 is 24, 3 times 4 is 12, plus 2, 14. So 144, that would be. Remember, this is a non-calculator paper, and I keep my pi. Okay, so these are the surface area of all these things, but it says the total surface area of the cylinder is twice the total surface area of the sphere. So that means that if I halve the surface area of my cylinder, I'm going to get the surface area of the sphere. And I'm going to do that, so I divide everything by 2. 6 divided by 2 is 3, so 3 pi h, plus 18 divided by 2 is 9, so that's 9 pi. I now have to set up an equation. So I'm going to make the surface areas equal now, because they are at this point after I've halved everything. So I'm going to say that 144 pi is equal to 3 pi h plus 9 pi. Now, as you can see, I can get rid of the pi's, because if I divide all my terms by pi, then that would cancel out. That would become 1. So really, these pi's here aren't necessary. So this can now turn into 144 equals to 3h plus 9. I solve it as a normal equation, so I take away 9. And I get that 3h is equal to maybe 135, I think. 135. And if I divide by 3, I'm going to get that the height is equal to, kind of bit of quick mental division. So how many 3's in 13? And that's 4 remainder 1. How many 3's in 15? And that's 5. So the height is 45. So this is no longer h, that's now 45 centimeters, of course. Great. So now I need to find a bit more space to write on, first of all. And I'm moving to doing some volume calculations now. And I'm going to need some separate space. So it says, work out the ratio of the volume of the sphere to the volume of the cylinder. So I need to substitute my newly found information into the formulas for volume. So the volume of the sphere, let me keep color coding them. So I'm doing the sphere first. The volume of the sphere is 4/3 pi times the radius cubed. The radius is 6 cubed. And then that's 2, this dot dot. The volume of the cylinder. And the volume of the cylinder is pi times the radius squared, so times 3 squared, and then times the height, which I now know is 45. So there's going to be a lot of simplifying now. So I'm going to have a quick look. First thing I could simplify is the pi's, because if I divide both sides by pi, the pi's would cancel out. And I'm left with this beauty, which doesn't look much more encouraging than it did before. I don't even know what to do first, like where do I start? I'm going to do 3 squared times 45, so that's 9 times 45. I'm going to do that somewhere. Obviously, you'd have more working out space, so it doesn't need to look as messy as mine does. So 45 times 9, 9 times 5, 45, 4 times 9 is 36 plus 4, 405. So that's 405. And now I need to do this beauty, which is 6 cubed. So I know 6 squared is 36. And I need to do 36 times 6 again. 6 times 6 is 36. Write down 6, carry 3. 6 times 3 is 18, plus 3, 21. So that's 4/3 times 216. Now, I know that 3 goes into 216. And I'm going to do that. So how many 3's in 21? And that is 7. How many 3's in 6? That's 2 of them. So now all I'm left with is 4 times 72. 4 times 72 times 4 rather. So that's 8. And that's 1. So 140. What? I was just checking that you guys are still paying attention. Let's pretend that never happened. So 72 times 4. 4 times 2 is 8. 4 times 7 is 28. That's what I've been saying all along. Okay, so now I've got this 288 to 405. Give my answer in its simplest form, of course. So again, my numbers both divide by 3. I can't think of a bigger number that they divide by, so I'm going to take it step by step. Just simplify bit by bit to make sure I don't make any mistakes. So how many 3's in 28? I think that's 9 with a remainder of 1. And how many 3's in 18? That's 6 if I'm not mistaken. I'm going to do the same to the other side. How many 3's in 4? That's 1 with a remainder of 1. How many 3's in 10? That's 3 with a remainder of 1. How many 3's in 15? That's 5. Well, this is fabulous. But it looks like they divide by 3 again, so I'm going to do that, but I'm going to go all the way here. So how many 3's in 9? 3. How many 3's in 6? 2. And I'm moving on to doing 135 divided by 3. How many 3's in 13? And that's 4. Remainder 1. How many 3's in 15? And that's 5. And believe it or not, we've finally reached the answer, because 32 and 45 do not have another common factor that they could be divided by. So this is it for question number 15, 16 even. A bit of a lengthy one, but here you go. Hopefully that makes sense. And I'll see you for number 17. Bye.